What is conditional probability? Let's start with the basic idea. Conditional probability is the probability that some event B will happen. Given that we already know event A has happened, we write this as P of B given A. That vertical bar in the middle means given that. So when you see P, open parenthesis B, vertical bar A, close parenthesis, you read it as the probability of B given A. Here is the formula. P of B given A equals P of A intersection B divided by P of A as long as P of A is greater than 0. In plain words, we are asking, out of all the times event A happens, how often does event B also happen at the same time? Think of it this way. Imagine you are in a room with 100 people. You want to know the chance that a random person likes math. Easy enough. But then someone tells you, the person we're looking at is already wearing glasses. Now your picture has changed. You are no longer looking at all 100 people. You are only looking at the ones wearing glasses. Your world just got smaller. That is exactly what conditional probability does. It shrinks your focus. You narrow down to only the outcomes where A already happened and then ask, within that smaller group, how often does B also happen? Let's look at our first example. A vehicle is entering a place called Luray Caverns. Here is what we know. The probability that a vehicle has Canadian license plates is 0.12. The probability that the vehicle is a camper is 0.28. The probability that the vehicle is both a camper and has Canadian plates is 0.09. The questions are A. What is the probability that a camper entering the Luray Caverns has Canadian license plates? B. What is the probability that a vehicle with Canadian license plates entering the Luray Caverns is a camper? C. What is the probability that a vehicle entering the Luray Caverns does not have Canadian plates or is not a camper? Defining our events, let A be the event that the vehicle has Canadian license plates. P of A equals 0.12. Let B be the event that the vehicle is a camper. P of B equals 0.28 and P of A intersection B, both at the same time, equals 0.09. Question A. From the phrase a camper entering Luray Caverns, we know that the vehicle is a camper. Given that, what is the probability that it has Canadian plates? P of A given B equals 0.09 divided by 0.28, which is 9 over 28. So roughly 32% of campers entering Luray Caverns have Canadian plates. Question B. From the phrase a vehicle with Canadian license plates entering Luray Caverns, we know that the vehicle has Canadian license plates. Given that, what is the probability that it is a camper? P of B given A equals 0.09 divided by 0.12, which is 3 over 4 or 0.75. So 75% of vehicles with Canadian plates are campers. Question C. What is the probability that the vehicle does not have Canadian plates or is not a camper? We use a rule called De Morgan's law. The event not A or not B is the same as the complement of A and B together. So P of A complement union B complement equals 1 minus P of A intersection B. That is 1 minus 0.09. which equals 0.91. There is a 91% chance that the vehicle either does not have Canadian plates or is not a camper, or both. Here is another example. This example involves 3 subjects in a class of 100 students. 42 studied mathematics, 68 studied physics, 54 studied history, 22 studied both mathematics and history, 25 studied both mathematics and physics. 7 studied history but neither mathematics nor physics. 10 studied all 3 subjects. 8 did not take any of the 3. What is the probability that a randomly selected student is taking both history and mathematics, given that the student is not taking physics? Let M be mathematics, H be history, and P be physics. The given condition is P complement, meaning the student is not taking physics. So we focus on the 32 students not taking physics We are looking for H intersection M. Students taking both history and math is 22. But 10 also take physics. So 22 minus 10 equals 12. So the probability is 12 over 32, which simplifies to 3 over 8. For the last example, this is about a married couple watching TV. The probability that a married man watches a show is 0.4. The probability that a married woman watches the show is 0.5. And the probability that the man watches the show, given that his wife is watching, is 0.7. Now, consider the following events. Let A be the man watching. Let B be the woman watching. We are given that P of A given B equals 0.7. This means that if the wife is already watching, there is a 70% chance that the husband is also watching. Question A, we want P of A intersection B. The probability that both the husband and wife watch, we can rearrange the conditional probability formula. Since P of A given B equals P of A intersection B over P of B, we multiply both sides by P of B. P of A intersection B equals P of A given B times P of B. That gives us 0.7 times 0.5, which equals 0.35. So there is a 35% chance that both of them watch the show. Question B. Now we want P of B given A, the probability the wife watches. Given that the husband is watching, notice the flip. This time, A is the given condition. We know the husband is watching. A is known, and B, the wife watching, is what we are looking for. Using the formula, P of B given A equals P of A intersection B divided by P of A. That is 0.35 divided by 0.4, which equals 0.875. So if the husband is already watching, there is an 87.5% chance his wife is watching too. Summary: conditional probability answers the question. If we already know something happened, what is the chance something else also happens? Always identify the given condition first. That becomes your denominator. Then identify what you are solving for. That becomes your numerator. And remember, P of A given B is not equal to P of B given A. Like, comment, share, subscribe.